Now, this first equation is V equals to V naught plus AT. So this, in our local textbook, we use V equals to U plus AT, right?
Okay.
Okay, but I don't know which version you have come across before, the red or the blue one.
We use both.
Both, okay, right. We stick to your textbook, the red color. Okay, what is V? V is the final velocity, right? Final one. V naught is the initial velocity.
Initial velocity.
So if you travel a certain distance, the starting velocity is the V naught, the ending velocity is V, right? And in between them, if you accelerate, then the acceleration is represented by the symbol A.
Right.
And the time taken for the journey is T. Okay. So this is the first formula. We look at, so we look at the second formula, okay? In our local textbook, we call it S equals to UT plus half AT
T
squared.
plus half AT squared. Yes, this one I know.
Then in your textbook, they use delta X to represent the displacement. And V naught is the initial velocity, T is the time, then plus half acceleration multiplied with the time square. Okay, so this is the second equation of motion. Okay. Next one. Next one is V square equals to V naught square plus 2AX or 2AS lah in our textbook. So the symbol is usual. As usual, V is the final velocity, V naught is the initial velocity, A is the acceleration, and delta X is the displacement. Okay. Now there is one that is not inside the textbook, but it is given in the writing there, or the content there, it is given this formula also. So the displacement is half the initial velocity plus the final velocity multiplied with the time taken. So altogether we have 4 formula, but usually the first 3 are the ones that we use. Okay, right. Summarizing the formula, all together in these 3 formulas there, we have altogether 5 variables or 5 physical quantities. The 5 physical quantities, they are delta X, which represents displacement, V, which represents the final velocity, V naught represents the initial velocity, A represents the acceleration. Of course, the acceleration, they didn't say deceleration or what, but if you see the acceleration is a positive number, it means acceleration. If you see that the acceleration is a negative number, then it is deceleration. And T is the time taken or time elapsed. Now, of these 5 physical quantities, you are always given 3, at least 3. Now, all these 5, you're given at least 3, and you are asked to find one of them. They will give you 3, ask you to find 1. Although there are 5, right? They'll give you 3, ask you to find 1. So this is a summary of the
4 formulas.
This is the summary of the 4 formulas, right? So we're going to look at one simple example, right? So the simple example is, you read 10, example 10. Starting from rest.
Starting from rest, a sprinter reaches his top velocity in 3 seconds. He runs a distance of 24 meters in the 3 seconds. What is his acceleration?
Now, of course, if you read like that, you see only part of the picture. So it is better that we write out all the 4 physical quantities again, right? Delta x, v, v naught, a, and t. Now, as I read the question, I try to check which one of this physical quantity is given. Okay. A sprinter starting from rest, a sprinter. Okay, the first thing, starting from rest. What does this mean? Do you know what does this mean? Start from rest?
0.
0. What is 0? The initial velocity
Initial
is 0.
velocity.
Correct. A sprinter reaches his top velocity in 3 seconds. So 3 seconds, which one of these 5 is given?
His final velocity. His top the time is 3 seconds, sorry.
3. Okay, the time is 3. He runs a distance of 24 meters in the 3 seconds. 24 meters, which one is given?
His distance, final displacement, 24
correct.
meters.
The distance or the displacement. So these are the 3 given physical quantities. They ask us to find what is his acceleration. So we are supposed to find this one, right? So true enough, they gave us 3 physical quantities, asked us to find 1. So,
okay.
This is it. The initial velocity 0. Don't care about the final velocity. A t is x. So which of these formulas, this 4 here, which of this formula relates these 3 physical quantities and the one that we want to find?
We want to find his final acceleration. So we can do, we don't know final velocity, right? So we can only use the second one, no?
Correct, we use the second one. So when you use the second one, you just copy down the second one, right? This is delta x v naught e plus half at squared. And since we have tick the thing and fill up, then tick and fill up, tick and fill up. So I just pick the numbers from here and fill it up inside the formula. Delta x is 24, so I put 24 there. The time is initial velocity 0 times 3. So this one will be 0 lah. Then half a t square, half a t square. So the 3 square lah. So 3 over 2, this will be 3 over 2, 24. Then just bring over, you have the acceleration is 5.3 meter per second square.
Okay.
So this is what we are going to do, right? So you read example 11.
Selena is driving at a velocity of 10 meters per second. Seeing a cow in front, she brakes to stop a car. If the deceleration of the car is 2 meters, what is the distance of the car covers? What is the distance the car covers before it comes to a halt?
Okay, right. So this one is they have drawn for us. Okay, at first 10 meters per second. So you want to come to a stop so that you won't hit the cow. Okay, so what is the distance traveled, right? If your deceleration is 2 meters per second square. So let's say, again, we cannot see the overall picture. So you list out all the variables, all the unknown, all the physical quantities in this question, right? So first one, driving at a velocity of 10 meters per second. So this one is the velocity. So you only need to decide whether it is the initial velocity or the final velocity.
Initial.
Yeah, initial velocity, correct. Initial velocity. Then next one, seeing a cow, she brakes, decelerate.
Final velocity.
They said decelerate. Deceleration of the car is 2
Oh,
meters per second square.
Okay.
So what is it?
So
Which one? A is this one. What is the distance covered before it comes to a halt? Halt means what?
0.
Yeah, the final velocity is 0, correct. The final velocity is 0. Then the deceleration is 2. What they ask us to find? What is the distance? So we are supposed to find this one, right? So again, we are given three physical quantities. Ask you to find the fourth one. Okay, so don't have to worry. They are manageable. They are within your imagination, right? So only 3 of them and the fourth one. So what I fill up the numbers first lah. Delta x, don't know. The final velocity come to a halt, that means 0. Initial velocity, the starting velocity of the car, 10. And decelerate, you have to put a negative there.
Negative sign.
Negative. If you put a positive there, that means you are accelerating. So you put a -2 there. The time, you just ignore the time. Just ignore the time because you're not going to use. Then we look at, of course, you have written down everything. Then you check with the formula. Which of these four formula? Third one, very fast. Yeah, correct. It's the third one. Very good. Okay. So I'm going to copy down the third formula and fill up with numbers. Okay. So the third formula is v squared u squared 2as. So the final velocity I replace with 0. Initial velocity I replace with 10. Acceleration I replace with -2. So you have to be careful, it's a negative number. -2 times -2 times 2 is -4. But I move over to the other side of the equation, it becomes +4 delta x. Okay, +4 delta x. 100 square, 10 square is 100. Divide by 20, divide by 4, it will be 25 meters. So this is how we're going to do the questions. The one that is given in the exercise book, in the textbook, they involve 2 vehicles and overtake one another. So it's a bit advanced already. So we start with 1 vehicle first. Then after you are familiar with the formula, then you go back to the textbook. Since you have mastered all the equations, they are all inside your mind. So when you go through the textbook again afterwards, maybe you will understand, right? So you try to remember the formula, and if you try to visualize them a few